Welcome. This lesson is on slope. And slope is the measure of the steepness of a line. So if I'm going to take an axis where I have my y and my x, and I have a line going like this, I can also compare it to a second line that might start at the same place, but goes like this. From here I can see that the red line is much steeper than the green line. So it actually has a much higher slope. So the slope is a measure of a steepness of a line. We can also calculate slope through the equation of rise over run. Basically, rise over run is how high does the slope go over how much distance does it cover. So it's mainly about steps, like so how high does it go for however many steps you have. Slopes that go up and to the right, these guys are positive. Any slope that might go down to the right is a negative slope. So it's actually going down. You can think about it as the positive ones, you're going uphill. The negative ones, you are going downhill. So let's look at an example of what we can do to calculate a slope. So here I have a grid, and I have a line. And this line, let's say, starts here at 1 and 2. So I can put in all my grids. 1, 2, 3, 4, 5, 6, and this is 0. Like so. I have a point here that goes from 1, 2, and then I have another point. Let's make it here at 3 and 5. And so this is my line. And I want to find the slope of this line. So the slope is going to equal to the rise or over the run. Now the rise is how many squares does my slope go up. So I'm going to count from here, from the top, and down. So I have, going from here, 1, 2, 3 squares. So my rise is equal to 3. The run is how far I'm going from left to right. So I'm starting here, and I go 1, and then 2. So I go 2 here, and then up 3. So my slope is going to be 3 over 2. So that's my slope. And I figured it out by counting however many squares I went up and how many squares I went to the right. So that seems pretty easy, how high I go up, and then how far do I go to the right. Let's say I had a different line. In this case, I'm starting from 4 and 5, and I'm going down to 8 and 3. So this is giving me a line, and it's going to be a negative slope because I'm going down. So in this case, my rise is not so much a rise, but a fall. I'm going down 1, 2 lines. Red, 2 lines, and then I'm going over 1, 2, 3, 4. So in this case, for the green line, my slope is going to be equal to the 2 I went down, which is negative, down is a negative, and I'm going over 1, 2, 3, 4. So my slope is negative 2 over 4, and I can simplify that to negative 1 over 2. That's not too bad. But what happens if I give you just a point and a slope? So let's erase this part of it here. And I'll erase this. Let's say I'm going to start at, I don't know, 2 and 1. And I know I have a slope, and it's equal to 3 over 4. So I know my rise is 3 and my run is 4. So from my point here, I'm going to rise 3. 1, 2, 3. And I'm going to run another 4. 1, 2, 3, 4. So where I end up is my second point of my line. I connect the dots. And the second point in this case is going to be 6, 4. So using my slope equation, rise over run, and a starting point, I can actually get to the next point on my line just using this slope.